Welcome. In this video, we're going to look at some simplifying with exponent rules combined. So to start this off, I just want to remind ourselves of the things that make exponents simplified. So if we flip back to our division properties of exponents, we can look at what things make something simplified and what things we need to make sure that we do along the way here. So the first thing is that we can't have any negative exponents in our final answer. The same base does not appear more than once in a product or quotient. So that means I shouldn't have an x to the second and an x to the fourth. They should be combined. No powers are raised to powers. So I can't have anything that looks like this, a to the third to the fourth. That's a power to a power. No products are raised to powers. So I also don't want anything like this. No quotients are raised to powers. So same thing, but with division. And numerical coefficients in a quotient, you don't have any common factors other than 1. And so this is what we talked about here. If I have a coefficient of a 2 and a 4, that should be simplified to 1/2. So numbers still do what numbers have always done. Okay, so let's keep those things in mind as we start to do some simplifying with multiple exponent rules in one. So when we're simplifying, the hard thing is there's not a specific order that you have to do them. So we just have to be careful that we're doing each exponent rule correctly. We do still want to follow our order of operations here. So if you look at this first one here, right, I have some multiplication of these two big things, but I also have some exponents within those things. So exponents are more powerful in multiplication. I need to do those exponents within the two terms themselves before I combine them. But there is a lot of flexibility within that. So try to simplify each part. So if you have some multiplication, division, do that as much as possible. And including inside parentheses. Then combine using your operations. So then do the multiplication, division, and continue to simplify if necessary, thinking back to that list that we just talked about. Okay, so that's where these do become a little tricky because it is not just one thing that you have to do first. So when you're taking a look at this, just look at one thing that's not simplified and try and simplify that one thing, and then take a look at what's left. So if I'm looking here, I'm going to say, oh, okay, this is a power, well, it's actually a power to a power and a product to a power, but we have this exponent with these parentheses. That's not simplified. I'm going to deal with that first. So I'm going to write in a little 1 there and a multiplication sign just to remind myself that y is to the first power and we're multiplying. There are two factors there. So this 3 needs to go to both of them. I'm using my power to a power rule there and saying it's 2 times 3, so x to the 6 times 1 times 3, y to the third. Okay, again, if you don't remember what the rule is or are not confident with that, go back to what does it mean. It means x to the squared y times itself, x to the squared y, x to the squared y, 3 times. Right? I'm also going to do the same thing over here. I'm just going to leave it negative for now and put that in here. So then I have x to the negative 6, y to the negative 4. You could have dealt with the negative first, put it in a fraction. I chose not to. Okay, up to you. Okay, now this is all multiplication. You can see I added these multiplication symbols there. That's totally fine now that I don't have those parentheses with the exponents. So here we have some options again. We could deal with the negatives first. I'm going to combine my like bases first using our product rule here. So if I have a product, I'm going to add my exponents. So I have x to the 0, y to the negative 1. Okay, and then once we're there, anything to the 0 power, any non-zero to the 0 power is 1. So now I just have y to the negative 1. Can't have a negative exponent, so we go one step further. Say that is 1 over y. Okay, one little thing at a time until you have nothing left to do. Right? Let's take a look at a few more examples here. So negative x squared to the 4th times negative x squared to the 6th. Okay, start off. Think about your rules. Squared to the 4th, this negative is a negative 1. I'm just going to throw that out there and say I have a negative 1 times x to the 8th using my power to a power, 2 times 4, times negative x squared to the 6th. This negative is coming with me, so this means I have negative x squared times itself 6 times 1, 2, 3, 4, 5, one more. So I have a negative, positive, negative, positive, negative, positive. So it's going to be positive x to the 12th. Okay. Now it's all multiplication. Like bases, I'm just going to add my exponents. X to the 20. Negative out front is totally fine. Excuse me. You could write it like this, or negative x to the 20th is the same exact thing. So either way is completely fine. Okay, let's take a look at a couple more examples, combining these rules. Okay, so here we have some fractions with our exponents. So keep in mind our exponent rules there. So I'm going to deal with my negative part, just that negative part on both of these first. So negative exponent changes division, multiplication, multiplication to division. So this is going to become 3 over 2 to the positive 2 times 2n over 6m to the positive 3. Okay, again, that's not your only entry point. It's just where I chose to start. Okay, next I'm going to look at this 2/6 because I want to simplify that first inside there. So I still have 3 halves to the second. 2/6 is the same thing as 1/3, so I have n over 3m. Okay, again, just taking one thing at a time. Okay, now I'm actually going to deal with this exponent that we have here and do this 2 to everything inside. If it helps, write in those little ones. Keeping in mind this is 3 times m there, so 3 has 1 too. So now I have 3 to the second over 2 to the second times n to the third over 3 to the third times m to the third. Oh, it's all multiplication, so I'm just going to put that guy all together and say this is 3 to the second times n to the third over 2 to the second times 3 to the third times n to the third. And actually leaving it just like that is going to be helpful here, that we can see these like bases with my 3's and say this is 3 times 3, this is 3 times 3 times 3. 2 of those divide out, and I'm left with n to the third over 2 squared times 3n to the third. Getting closer. The only thing I can have left that I can do is actually figure out what is this. So 2 squared is 4 times 3 is 12. So this is n to the third over 12m to the third. No negatives, no like bases. We're all done there. Okay, last one here. This is a big one. I would encourage you to pause right now, try it on your own, and then come back and check your answer. Take one little thing at a time. And again, if your one little thing at a time doesn't match up with my one little thing at a time, that's okay. Okay, you're just going to pick something that's not simplified and do that thing, and then pick something else that's not simplified, do that thing. Okay, I am going to choose to start right here in the denominator because I have a power to a power. So I need to do those exponents before I can do any of my division. So 7x to the negative 3, y to the 4, z to the second. I'm going to leave that numerator all alone. And so this is 2 squared x to the 6th, y to the negative 10th. Okay, once we're there, now I'm going to pick something else that's not simplified. I'm going to deal with my negative exponents next. Okay, so I have 7 y to the 4th, z to the second. Remember that 7 does not have that negative exponent. Y to the 10th is going to come up top to become positive. And then I have 2 squared x to the 6th. And then x to the third is going to become to the bottom to become positive. Hey, what else is not simplified? I have y's and x's that are like bases. So let's deal with those. 7z squared, 4, 10, 14 factors of y. 2 squared, I'm just going to do that now too, is 4. 6, 9. Okay, and that is all we can do there. No like bases. 7 and 4 don't have any common factors. No negative exponents, no zero exponents. I think we are good to go. So that is all I have for you today. Thanks for following along with these examples.